Black holes are some of the strangest and most fascinating objects in space. They're extremely dense, with such strong gravitational attraction that not even light can escape their grasp. The Milky Way would contain over 100 million black holes, though detecting these gluttonous beasts is very difficult. At the heart of the Milky Way lies a supermassive black hole, Sagittarius A*. The colossal structure is about 4 million times the mass of the Sun and lies approximately 26,000 light-years away from the Earth, according to a statement from NASA. The first image of a black hole was captured in 2019 by the Event Horizon Telescope (EHT) collaboration. The striking photo of the black hole at the center of the M87 galaxy, 55 million light-years from Earth, thrilled scientists all around the world. Any matter that crosses their event horizons, also known as the point of no return, spirals helplessly toward an unknown fate. Despite decades of research, these monstrous cosmological phenomena remain shrouded in mystery. There is a lot of information and misinformation out there about black holes. Let's debunk some of the myths and talk about some of the strangest things about black holes. Number 1. You can't directly see a black hole. A black hole is called so because of its color, especially since light can't escape. What we can see though is the effects of a black hole. Analyzing the surrounding area, we can see its effects upon the environment. For example, a star that's close enough to a black hole can be seen being ripped apart. Number 2. Some think that black holes are like cosmic vacuums that suck in the space around them, when, in fact, black holes are like any other object in space, albeit with a very strong gravitational field. If you replace the Sun with a black hole of equal mass, the Earth would not get sucked in. It would continue orbiting the black hole as it orbits the Sun today. Black holes look like they're sucking in matter from all around, but that's a clear misconception. Companion stars shed some of their mass in the form of stellar wind, and the material in that wind then falls into the grip of its hungry neighbor, a black hole. There can be 3 types of black holes. First is primordial black holes. These are the smallest and can range from an atom size to a mountain's mass. Then you have your stellar black hole. These are the most common ones and can be up to 20 times more massive than the Sun. There are also a variety of these all over the Milky Way. Lastly, supermassive black holes are the largest of black holes, being more than 1 million times more massive than the Sun. The closest black hole, V4647 Sagittarii, was thought to be 1,600 light-years away from the Earth, but it is apparently further away than was expected. Scientists now believe that this black hole is about 20,000 light-years away. Black holes can also be quite funky when it comes to time and space. Say someone falls into a black hole and there's an observer that witnesses. The person who fell into the black hole's time slows down relative to the person watching. This is explained by Einstein's theory of general relativity, which states that time is affected by how fast you are going when you're at extreme speeds close to light. And unlike popular belief, Einstein did not discover the existence of black holes, though his theory of relativity does predict their formation. Carl Schwarzschild was the first to use Einstein's revolutionary equations and show that black holes could indeed form. He accomplished this in the same year that Einstein released his theory of general relativity in 1915. From Schwarzschild's work came a term called the Schwarzschild radius, a measurement of how small you'd have to compress any object to create a black hole. There are 2 theories on how binary black holes form. First suggests that the 2 black holes in a binary form at about the same time from 2 stars that were born together and died explosively at about the same time. The companion stars would have had the same spin orientation as one another, so the 2 black holes left behind will as well. Under the second model, black holes in a stellar cluster sink to the center of the cluster and pair up. These companions would have random spin orientations compared to one another. Black holes have also been theorized to be able to give rise to wholly new universes. A very simplified version of how this works is that our universe today, when you look at the numbers, has some extremely convenient conditions that came together to create life. If you tweaked these conditions by even a minuscule amount, then chances are we wouldn't be here. The singularity at the center of black holes break down our standard laws of physics and could, in theory, change these conditions and spawn a new, slightly altered universe. Black holes remain a deeply intriguing part of space science. It might sound unreal, but black holes could indeed spawn new universes especially since we're not sure other universes exist. But the theory behind this is an active field of research today. Thank you for making it till the end of the video.